Okay, I should have known it was going to happen. I'd make a video, talking about reproducing these, and yes, my email box just about exploded today with questions. What exactly do they do? How do you hook them up? All kinds of suggestions. Suggestions are great. I can use all the suggestions. Some ideas were good. Like one, it was a great idea. I didn't even think about it. Was if I do decide to start making these, just basically assemble the parts, get the cabinets made, but make it a kit so you can build it yourself. I think that was a fantastic idea. Matter of fact, that's probably the best idea I've heard. I can't believe I didn't think of it because I love kits myself. Anytime I buy something, if I can get it in kit form, I always buy it in kit form. But in any case, I wanted to answer some of the, I guess you could call it more technical questions. Now, this is not the one you saw yesterday. This is another one. Like I say, I have several of them. To prove that, I'll flip it around so you can see there's no gigantic hole here where somebody butchered into it and installed a microphone jack. This one's pretty much virgin, other than I have replaced the electrolytic capacitors in it, but other than that, still 100% original. I guess the first thing I should cover, and it probably would have really helped if I did that yesterday on the other video, was what exactly is a compression amplifier and what does it do? So I'll make it really simple without getting too technical. I'll just try and sum it up in a nutshell. So we can probably just do this on a Post-it note. So if you have, when you're talking, okay, you have varying audio levels. It's not only frequency, because of course your voice has a frequency range it's made up of, but when you speak, there's different levels. So if you look at that on an oscilloscope, you'll see waveform going up, and you'll see all kinds of stuff like this on a scope screen. You can't really see anything, can you? Being blinded by the light. There we go. So something like that. Now, ideally what you want is, now this is not the modulation package. This was as if you were, let's say, looking at an oscilloscope. Here's our 0 axis, let's say. And these are your positive peaks and negative peaks. But so let's say, you have your radio set up perfectly for 100% modulation. Now, a lot of people say, oh, well, you can get more than 100% modulation. Yes, you can. And you'll still sound fine. The problem is, it does you no good on the channel you're on. Once you exceed 100% modulation, your radio turns into a shotgun. So you've basically installed a 12-gauge shotgun barrel on your coax connector jack on the back, because now you start to splatter or spread across the band. And the more you over-modulate, if you look at it on a scope, you'll start to see your waveforms are clipping. So instead of coming up the nice round crest like that on a modulation package, you'll see, it'll start to box. You'll hear people say boxcar. So you'll have, if this is the 0 axis and you're looking at a scope, you'd see a positive comes up to a peak, but then it boxcars like that, and same thing on the negative side. You see it's called flat topping or boxcars, because that's what it starts to look like. And when it gets really bad, you'll see a big 0, and then it'll just basically come straight up, straight down, and that's basically what it looks like, because you're flat topping, and they look like boxcars or rail cars. Now, like I say, this is a modulated waveform package down here. This would just be looking at your audio. So if you were to hook your scope probe up to, let's say, your microphone. But when you reach these peaks, once you exceed a certain amount, once it goes through the mic amplifier and the radio and the audio, depending how many stages there are, because there can be from 1 to numerous stages. And it gets through the final amplifier, and it will finally go into an old tube radio, plate modulation, or there's lots of different modulation types, and solid state radios that come out of usually like an IC. And then it'll go over and it modulates the final circuit, or your carrier. The problem is, once you start to get too much audio, once the amplitude gets too high, you're overdriving your carrier, and that's when you start to overmodulate. And that's where you start getting funky looking waveforms. And like I say, you can actually fairly severely overmodulate your carrier and still sound fine on air, on channel. The problem is, if you were to flip one channel down or one channel up from the channel you're on, you'd also hear yourself on there. because you're now splattering. A lot of that extra energy is just splattering across the band. So we want to try to prevent that. But what we also want to do is try and increase these little tiny signals. That's what the compression amplifier does. So we don't want these to get too high, your high peaks, but we want to try and increase some of these lower signal levels. We want to try and increase them a little bit, but without overdriving these. Now, if you use the mic gain on your, let's say your radio, if you have a power mic, it has a gain control on it. Well, if you're trying to increase some of these lower amplitude audio signals, if you're trying to increase them by increasing your mic gain, the problem with that is it increases the gain of everything that goes into the mic. Or, if there's a mic gain on your radio, it's increasing the amplifier, how much that's amplifying everything. It's not just increasing these little small, and helping to boost this up a little bit. It's increasing these large peaks in your voice that are already large, and that's where you'll start to overmodulate. What the compression amplifier does is it will reduce the gain of the amplifier tube in this compression amplifier. Okay, it reduces the gain when it basically senses one of these large peaks, but then increases the amplification on the lower peaks. So it helps to level it out. Now, it's not going to be a flat line, because if it was a flat line, you wouldn't hear anything. Everything would be at the exact same level. It would be a varying frequency, audio frequency, but it would be exactly level. But you want to try and increase these some. So that's what the compression amplifier does. Now, what makes this one kind of unique, the majority of compression amplifiers that you see, they only have one knob and two connections. Usually you plug in a mic cord like this into the front of it, and then either out of the front or the back, a cord comes out that looks just like this, and you plug that then into your radio. That's the output. The problem with those is they have no way of sensing what's going on in your radio. It really doesn't know if your radio is starting to overmodulate. It has no way of sensing those peaks. So that's where this one's kind of unique. It has the negative feedback bias circuit. So this has 3 wires coming out of it instead of 2. Okay, so like in the one I had where I just was asking would people be interested in these, that one had 2 wires and a mic jack on the back. Basically the same thing. This one just has this, because this one's unmodified. It just has 3 wires coming out of it. So 2 of them are just like any of them are going to have. There's an input and an output. Okay. So I actually had this in a radio at one time. It's going to be installed into another one. But I just have a coupling cap. So inside of a radio. So let's use we'll use a solid state one. And there's differences, even some more differences I'll need to cover here in a second. But for conversation right now, if I can find what I did with my service manual here. So let's use something like Cobra 25. Okay, this is a factory service manual here. Very simple radio, not a lot to it, not a boatload of fancy features. And what makes this one easy to talk about is because the mic amplification circuit and modulation circuit is so simple in this. You have your mic connector, so basically your audio comes in right here, runs into TR13, which is the microphone amplifier. It's amplified, it comes out, goes through C89, through R53, up to the audio amp IC. Comes out of the audio amp IC, comes down through this diode, comes across, and over to your final circuit. So it's very simple. Now, you can hook up these compression amplifiers in different places. Now this one, you're kind of limited because there's only basically two amplifier stages in this, the mic amp and the audio amp. So you could hook it up directly at the microphone input. You could wire it up so you plug your mic into basically the compression amplifier, and then the output from the compression amp plugs into the mic jack on the front of your radio. Or, which is kind of the way I prefer to do it, I like to install it after at least one stage of amplification in a radio. So what I would do, like in this radio, is I would pull C89. I would have this line here that comes out of the mic amp, this mic amp in the radio. That's where I would attach my input to the compression amplifier, and I'd have a coupling cap. Actually, that's why there is a cap on one of these wires here. So basically I would take this capacitor here, would hook up right here where this cap was removed, and then on the other hole in your circuit board, that's where the output from the compression amplifier, which has now been compressed and amplified, would go into this side, and then continue on to your amplifier and on across. Now, the problem with those is, like I say, that's a standard compression amp. It has no way of sensing what's going on once it gets through this amplifier stage, okay? Now, you have modulation limiters, but still, it doesn't really have any idea of knowing when it's reached a peak. So that's the big advantage of the Elenco Power Gainer compression amplifier. It has a third wire. Now on this one, I had this one hooked up. I just had an RCA jack on the back of the radio this was hooked up to, so that's why this has an RCA plug on it. What this hooks up to is the modulation. After it's been amplified in the radio, this hooks up to sense that. So like the center pin of this, or the center wire of this coax cable, in this radio, where I would hook that up, would be right here where that little black dot is. So after it's been amplified, it comes through, and this is the output. This is where it comes over to modulate your carrier, right there after that diode. You could do that right on the top of the circuit board, just tack it. Basically tack a capacitor onto the top of that, a small decoupling cap, like a 0.01 microfarad cap, onto this side of the diode. Run that up to the coax cable, and then in my case I like to make stuff easily removable. I'd just add an RCA jack on the back, or you could hardwire it. You could run this coax cable straight down to a coupling, this little 0.01 ceramic cap straight down to that diode. But what that allows is, and that's one of the main reasons, it has two tubes instead of just one tube. The 6BA6 is the amplifier. The 6C4, that's what this wire is controlling. Okay, so your audio voltage, because that's what it is, it's just a voltage. Your audio voltage, it's a sample of that, comes in and is rectified in this tube and becomes a negative DC bias voltage. That negative DC bias voltage is what controls how much this tube is turned on, or how much that it amplifies. So when you hit a big peak, where did my Post-it notepad go? So when you're talking and you hit a big peak in your speech pattern, okay, you get that big peaks up here at the top, where you don't want to exceed that because you'll start to flat top your waveforms like this. What this will do is it'll start to shut this tube down, so it reduces its amplification stage. Down here where these signals are very small, it will allow this tube to go basically full open or full bore. So it allows maximum amplification, and that helps to, if you just use my tweezers, it helps to increase them. It helps to, increase them. Where these big signals, it'll actually help to squish them down a little bit. The idea being to have the highs and the lows a little bit closer together, which gives you more punch, more audio output. That's why compression is a great thing. But like I say, this one has the advantage of it's very easy to control it so you don't overmodulate, because this has that feedback. You really don't see compression amplifiers with 3 wires, an in and out and a control or a modulator. They don't have a sense for the modulation circuit. Now, another nice thing about this is you can use this on the receiver. Now, you really can't use it on one of these radios right here. You could some solid state radios, but that's mainly in tube radios. So grab another schematic here. We'll just use, let's say, a Tram D201, very popular radio. So, Tram D201, your audio's been demodulated. Eventually it ends up coming out, going through this switch, through the volume control, and comes down through this first audio frequency amplifier. Comes out of this amplifier, goes through the RTC, which in the trams, that's a receive tone control. So it's nothing fancy, it's just a tone control. But it comes out, so there's that little arrow there. And then it will go down to big schematic flipped around here and folded up properly. So that's, you can see right there, to our RTC, receive tone control. So that's where that line comes down. So that's the after the first audio frequency amplifier on the receive circuit. Okay, So that's the audio that, what's coming in. Comes over and comes down to this point right here. Now you'll also notice there's a couple extra stages here. So here's in this radio, here's the microphone amplifier. Now this is a solid tube radio, and that's where this one, you can use the compression amplifier on the audio receive circuit as well, because we have the mic preamp and the mic amplifier. So, audio comes in from your microphone, goes in, is amplified. It's up coming through the mic gain, comes down, is amplified again in the mic amp, comes out, comes down, and then comes over and goes into the audio driver. Now, what you could do on this radio, let's say, is break this line right here, where it's coming into the audio driver tube, have your tap, because remember, this is also to receive audio, comes down right here. So it would come out to the input on the compression amplifier, and then the output of the compression amplifier would come back in to feed this tube, and then it would be amplified. And then you would hook up the sense lead, or the modulation, basically I call it like a monitor line, off of the compression amplifier. You'd hook that directly up to the plate on the audio amplifier tube, which in the case of the tram is a 6L6. So it'll sense. It has a reference then. It knows when it needs to turn the amplifier tube on more, or turn it off, or or decrease its amplification, or the amount of gain. That's the big advantage. It can vary the gain. It's a variable gain amplifier based on an actual sampling of the modulation that's being created in the radio. That's the big advantage of it. So I hope that clears it up a little bit. Oh, and like I say, because it's hooked up to the receive, if we hook up at this point right here, this is the junction, or the union of the received audio and the transmit audio right here. Okay, so if we were to hook that up right here, it will also compress the received audio. So what advantage do you get there? Well, it's the exact same advantage that you get with transmit audio. It will take those really loud spikes in the audio. Same thing if you were looking at a spectrum analyzer or an oscilloscope, and you looked at, you talk into a mic and you look at the screen, you'll see the increasing and decreasing in amplitude, the signal strength. Well, it'll help to squish or reduce, because it'll reduce the gain in here of this tube, the 6BA6. It'll reduce the gain of that when it's a really big peak, but it's the kind of weak part of the audio signal that you're having a hard time hearing. It'll help to amplify that. So it does the same exact thing for your receive audio that it does for the transmit. So when you're transmitting, you're getting compression, which gives you good punch to get through the pileup, and the other guy can hear you really well. But by the same token, when the receive signal comes in, it does the same thing. The compression amplifier kicks in, it compresses that audio, helps to reduce the overdriving signal and increase the weak signal, the weak portion of the audio spectrum, and you can hear better as well. So it's actually a receive amplifier. But it's not a normal receive amplifier. A normal receive amplifier just boosts the incoming signal into the radio. All of it. The noise, the hash, and the trash. This one's, for starters, this one wouldn't be amplifying until it's gone completely through all of the IF stages. It's been demodulated, and it's now nothing but an audio signal. It's, what's coming into the audio driver. So, your radio's already done its job to remove as much of the adjacent channel splatter, the noise, impulse noise, stuff like that. So you're only using the amplifier on what you actually want to hear, the human voice portion. So, like I say, they make really good receive amplifiers too. Like I say, I don't want to call it a receive amplifier because that's not what it is. It's just a compression amplifier for your receive signal. So, I hope that clears up a little bit. Like I say, my email box exploded. How they work, what they do, and the compression voltage, like I was saying. So, your signal comes, your modulation, so you could basically think of hooking this coax, this little coax cable, this RCA line, right up to that line right there. So the audio voltage comes in, is rectified by the 6C4, but it then goes through the compression voltage control, and that's what this control does. This allows you to control the amount of negative bias that goes to the 6BA6 right here. So like I say, number 4 usually works out whole way to the right, whole way to the right on 4. Now, like I say, you can adjust the complete output gain, because this is the last thing before it goes. As a matter of fact, the coax cable that out for your audio out is actually attached. That's this black line right here. This black wire here is actually the audio out line right here. So that's, the last thing to touch that coax cable before it leaves. But so like I say, that's what the compression voltage does. And that's why they have voltage written on there, because it's allowing you to control that negative bias voltage that is controlling the gain of the 6BA6. So I hope that clears it up a little bit. For those of you that have a little bit of electronics theory behind you, can understand that. Like I say, that will definitely help clear it up exactly what this one does and why it works better than the majority of them. And for those of you that know absolutely nothing about any of this, it gives you a little heads up as to what's involved. It can be as complicated as you want to make it installing one of these. Like I say, I like to go inside the radio to hook up my audio in and out. You can do it at the mic jack. It's perfectly fine. I just find I have usually a little bit better luck with performance of how it works if I go after either the first or the second, and especially in like a tube radio. I really don't like to use the mic jack. I like to go after all the mic amps. So like in the case of this radio, there's 2 microphone amplification stages. I like to go in after that. But it would be fine. You could go in the middle. You could go after the first mic amp stage. But like I say, the problem is if you come in here, that's not going to do anything for the received audio. This is a key point right here. If you hook it up here, like I say, that gets you the receive audio compression then as well. So there's just a little bit more information on the Elenco power gainer compression amplifiers and how they work and why they have 3 wires instead of 2.